Imagine a world where particles can be in two places at once, where energy comes in tiny packets, and where two particles can communicate instantly across the universe. Welcome to the weird and wonderful world of quantum mechanics. Quantum mechanics is the science of the very small, atoms, electrons, photons, and particles smaller than atoms. Classical physics explains big things like cars, planets, and baseballs, but at tiny scales, the rules are completely different. Quantum mechanics explains phenomena that seem impossible in our everyday life. In quantum mechanics, particles can behave like waves, and waves can behave like particles. Electrons, for example, which are particles, can create interference patterns just like light waves. This dual nature is called wave-particle duality, and it's one of the first strange facts about quantum mechanics. Quantum particles can also exist in multiple states at the same time until we measure them. An electron's spin can be both up and down at once. Think of a spinning coin. It's both heads and tails in the air until it lands. This is called superposition. Energy in the quantum world comes in discrete packets called quanta. Electrons in an atom can only occupy certain energy levels, and when they jump from one level to another, they emit or absorb a photon. This is known as quantization. Heisenberg's uncertainty principle tells us that we cannot know both the position and momentum of a particle exactly. The more precisely we know one, the less precisely we know the other. This is a fundamental property of nature, not a limitation of our instruments. In quantum mechanics, outcomes are probabilistic, not certain. We don't know exactly where a particle is, we only know the probability of finding it somewhere. This is represented by the wave function, which mathematically encodes all possible states of a particle. Sometimes particles can become entangled, meaning the state of one particle instantly affects the other, no matter the distance. Einstein called this spooky action at a distance. Entanglement is now used in quantum computing and quantum communication. So in short, the quantum world is strange but fascinating. Particles are also waves. They can exist in superpositions. Energy is quantized. We can't know everything precisely. Outcomes are probabilistic, and entanglement connects particles instantly across space. Quantum mechanics shows us that the universe is far stranger than we ever imagined.